Okay, year 11, parametric representation. This is the next topic in our work in further functions. So parametric representation. So I've taken the liberty of writing some notes up here. You can go and read the notes in the textbook. They're pretty good. But if you want a shorthand version, so parametric representation, or as I prefer to call it, or as they call it, is parametric form, is writing variables by another common variable. Now, I started that by not saying particularly x and y because it can happen in any algebraic expression. You could have 3 or 4 variables written in terms of another variable. So parametric representation is a really good way of getting a whole lot of different variables all written in the one common variable, which helps when you're dealing with some pretty hard mathematics. Now, for the Cartesian number plane, well, we only have 2 variables, and they are x and y. So essentially, when we're writing Cartesian equations in parametric form, it's just writing x and y in a third variable. So here's an example. X equals 2p plus 4, y equals p minus 2, and that gives us our coordinate here, 2p plus 4, p minus 2. The other one, which is going to come up a lot when we're going to talk about circles, is x equals, say, cos, and I couldn't get theta with the typing, but x equals cos t, and y equals sine t, and that just becomes cos t sine t. But I'm going to talk about that in a little while. So let's have a look at some of these and what we're going to do with them. So the first thing I want to do is I want to go and have a look at what the syllabus says. So we'll go down here, and remember, I want you to be able to use our Google Classroom as a way to getting into these things. So if we go into here and come on, let me view the material. I'll get out of there. Hold on. Here it is. This is what we want. The extension 1 syllabus. So you go into here. Remember, it's better to go into the live document in case there's some version changes. We go along and we look at the content. So we're in extension 1 because this is extension 1 work. We go into the course content. We know we want further functions. Now remember, this is only extension 1. So there's further work with functions. Let's go in and have a look there. And it pops up. And where are we? Get out of there. That's not what I want. Here we go. So further functions. So, and here are our dot points that we were talking about before that we have to do, which is the reciprocal function, the square root function, the absolute value function, and adding and multiplying functions. And then there's inequalities. Inverse functions we haven't done yet, but parametric functions are down here. And what are they asking us to do? So here we go. Students understand the concept of parametric representation. Good. And we're going to examine lines, parabolas, and circles. And what do we have to do? We have to be able to understand that linear and quadratic functions and circles can be expressed in parametric or Cartesian form. That's going to be pretty easy. And we need to be able to convert between parametric form and Cartesian form for all 3 of those. And finally, we need to be able to sketch these. Well, if we can represent parametric function in Cartesian form, you should be well able to sketch the functions. So that's going to be actually pretty easy. So that's all we have to do. So let's go back and have a look. And the first thing I want to do is I want to talk about, a linear one. And I'm going to take the one that I've got here. So this is a linear representation, parametric representation of a linear function. So let's convert that back. So number 1, we're going to talk about linear. So linear functions now. So we've got x equals p 2p plus 4. And we've got y equals p minus 2. Now you should be able to see this very quickly. What we have here is 2 equations. We're going to solve them simultaneously. So what do we do? First of all, I want to rearrange equation number 2. So I'm going to add that 2 back, and I'm going to get p equals y plus 2. And then I'm going to call this equation number 3, and I'm going to sub 3 into equation number 1. And when I do that, I get x equals 2y plus 2 plus 4. So all I've done is I've put that in there where the p is. Now I just x equals 2y plus 4 plus 4, x equals 2y plus 8. Bring everything over to the x minus 2y plus 8 equals 0. And that's the general form of the equation, and we know that's a straight line, so we're pretty good with that. What about going the other way? What about representing parametric, representing Cartesian in parametric? So I'm going to take one of the questions that they had, I think. Is it one of the ones that they do here? I think it's 4t. I stole it from one of these equations. Anyway, I'll just do it. So imagine, and it's going to come up in the questions. Let's say we've got x equals, so this is number 2. That's example number 1. X equals 4t. And then we've got this equation 5x minus 2y plus 1 equals 0. Now that's the Cartesian form, the general form of an equation. And again, it's just simple solving simultaneous equations. I'm going to sub 1 into 2. Now, this x equals 4t, someone has decided that that's what they're going to call it. You could call it anything you want. You could say x equals 3t and sub it in there and get a parametric representation, or x equals a half t. Someone has decided that that's the best form that we're going to use. It's pretty. So now all that happens is I'm going to put that 4t in there. So I get 4t minus 2y plus 1 equals 0. That's 20t minus 2y plus 1 equals 0. This was an example question, and there's a misprint in there. Let's take the 2y over the other side. So I get 20t plus 1 equals 2y. And let's divide everything by 2. I get 10t plus a half equals y. Now I have a parametric form of the equation, and it's 4t, and I'm going to write another set of brackets here, 10t plus a half. That's my x, and that's my y, and that's the parametric form of the equation. You don't have to write it as a coordinate, and that question, yeah, see how they did it down here? I stole that from this one here. But they changed it to 10. Up here it's 1, and somehow it magically changed to 10 down here. Anyway, so that's linear. Linear is very easy. That's going between the two. And remember, if you're going to have to sketch it, all you have to do is get it in its Cartesian form. Once it's in its Cartesian form, you can sketch it. So that would be all right. Let's have a go at some of the questions. All right. So here's 1a. And what do we got? X equals 2t and y equals 3t minus 4. And they're going to want us to get, and I'm just going to show you where I've got this from. This is question 1a. It's way down here. There it is, 2t, 3t minus 4, because I'm going to eventually get down there after I do a couple of these. So again, I have to write t as the subject of the equation. So I'm going to call this equation number 1, I'm going to call this equation number 2, and I'm going to rearrange equation number 1. I'm just going to go, x on 2, well, that equals t. Call that equation number 3, and I'm just going to sub 3 into 2. Sub 3 into 2. And all of a sudden, here I go, y equals 3x over 2 minus 4. So y equals 3x on 2 minus 4. Now I'm going to multiply everything by 2 and get the equation in general form. 2y equals 3x. Don't forget to multiply this by 2 minus 8. And then general form states I'm going to have the positive, x is positive, so I'm going to bring the 2y over. I'm going to get 0 equals 3x minus 2y minus 8. And that's it. That's the answer to question number 1. What about going the other way? Well, they don't go the other way until you get to question 6. And in question 6, they said, here you go. Here's a Cartesian equation, 3x minus 4y plus 24. Okay, well, that's equals 0. That's a general form of an equation. We'll call that equation number 1. And then they say, well, why don't you use x equals 4t? Now, that's arbitrary. Someone's decided to do that. There's probably a very good reason. It might help out with something. But anyway, so all we do, we sub 2 into 1. So sub 2 into 1, and we'll get the y in terms of t. So I get 3 times 4t minus 4y plus 24 equals 0. That's 12t. I'm going to take that 4y over straight away. Plus 24 equals 4y. And look at this, it's going to work out really neatly because both these are divisible by 4. So I divide by 4 and I get 3t plus 6 equals y. Hence my equation, or if I wrote it as a set of coordinates, x is 4t and y is 3t plus 6. Done. But they just write x and y. Now, they're linear. Linear are pretty easy. What about quadratic? So for quadratic, and remember, we only have to do linear, quadratic, and circles. So, quadratic. Well, there's a bit of a hint you need here with quadratic. So I'm just going to jump in. I'm going to go with 2e. So here we go. X equals 4k minus 7. Someone's given us that. And y, this is the parametric form, equals 2k squared plus k. Now, here's the thing. When you're doing these ones, always use the linear bit. Don't try and make k the subject of this equation. That would be very foolish and very difficult. Always use the linear one. So this is equation number 1. This is equation number 2. I'm going to quickly make k the subject here. So I'm going to add the 7 and I'm going to divide by the 4. And now I've got my k as the subject. This is equation number 3. And I'm going to sub 3 into 1. And when I do that, now it's really easy. I get y equals, watch this, 2, the whole thing, x plus 7 on 4, all squared, plus x plus 7 on 4. Okay, so y equals 2, I'm just going to leave that as x plus 7 all squared on 16 plus x plus 7 on 4. This is going to cancel, so I'm going to get 8 on the bottom. So what I'm going to do is I'm going to multiply everything by 8, which is going to give me 8y. I'm I'm now going to expand this x plus 7 all squared. By the way, the 8 is gone now because I multiplied everything by 8. So it gives me x squared plus 14x plus 49. And here I multiplied by 8, so this is going to become 2 outside of x plus 7, because if I multiply by 8, I'm going to have 2 of those. So I get 8y equals x squared plus 14x plus 49 plus 2x plus 14. 8y equals x squared plus 16x plus 63. And that's how they write the answer in the back. I probably would have written it as y equals and just gone y equals an eighth x squared plus 2x plus 63 on 8. But that's what they went with. This is the answer that they gave in the work solutions. What about with quadratics? What about going the other way? It's actually really easy. I don't know what one this is. I've written C, so assuming it's 6C, let's have a look. 6C, I think this would be, because that's going back. So 6C. Yeah, this is 6C. This is the one I'm doing here. So go back up here. So this is 6C. And we're told y equals x squared. And they want you to write x in parametric form, 2t minus 1. Well, this is pretty easy. This is equation number 1. This is equation number 2. Sub 2 into equation number 1. What do we get? We get y equals 2t minus 1 all squared. You could leave it like that. You can just expand it. That's going to come 4t squared minus 2 times that, 4t, plus 1. And there's your parametric form. There's your x, there's your y. Simple. Righto, the last bit, circles. So I'm going to use their diagram for circles because it's pretty cool. We're going to go back here to this. And this is the important bit. So in the 1 unit circle, where we have a coordinate xy. Now, we've already talked about this in class. We can rewrite this. Well, what do we know? Just look at that little right-angled triangle in there. Sine theta equals y over the hypotenuse, which is y over 1. So sine theta equals y. Cos theta equals x over 1. So cos theta equals x. Now, because circles are just bigger or smaller versions of the same thing, we'll be able to write this really easily. So this coordinate can be written as cos theta sine theta. And if we get a bigger radius, it'll change, but not slightly. This also gives us, because we know Pythagoras, we know that in that 1 unit circle, x squared plus y squared equals the hypotenuse squared, which is 1, which is where we get the identity, because we know what x is, cos squared x plus sine squared x equals 1. And that will always be true. That's our Pythagorean identity, which you need to remember. And that's going to help us when we do these parametric versions of these quadratic circles. Okay. Let's go and, what happens if it's not 1? Imagine if this was r. Well, I'm not going to go through the proof, but it makes it pretty easy. Y, we'll do x first. I'll do y because it's here. Y becomes r sine theta, so whatever the length of the radius is, and x becomes r cos theta. And what happens if we move the center of the circle to a point A, B. So now radius is R, and we have a centre AB. Okay, well, our new y value will become B plus R sine theta, and x will become A plus R sine theta. So now I'm going to jump to question 4D, writing this in Cartesian form. And 4D, they give us x equals 5 plus 4 cos theta, and y equals 2 plus 4 sine theta. Now, if we look above here, if we look at this, well, you can just jump straight into it. Here's your A, here's your B. So this is a circle with a centre 5, 2. And here's your radius. So R equals 4. So you can just jump in and go, that's x minus 5 all squared plus y minus 2 all squared equals 16. But I think it's important, right? Don't do that. Do it like this. We're going to rewrite these equations. So what have we got? X equals 5 plus 4 cos theta, and y equals 2 plus 4 sine theta. Now, I'm going to call this equation number 1, going to call this equation number 2, and I'm going to rewrite cos theta here and get x in cos theta. So I'm going to go, minus 5, x minus 5, and divide by the 4, and that's my cos theta. Now, over here, I'm going to write, y minus 2 over 4 equals sine theta. But remember, we know our trig identity, cos squared anything plus sine squared anything equals 1. So therefore, to get rid of this, x minus 5 squared over 4 squared plus y minus 2 squared over 4 squared equals 1. Because that's cos and that's sine. And we just squared them both, and we know that that's true. So therefore we get x minus 5 squared on 16 plus y minus 2 squared on 16 equals 1. Multiply the 16s across and we get x minus 5 squared plus y minus 2 squared equals 16. And you can sketch that really easily. You should be good at sketching that. I'm not going to do any of the sketching questions because once you write it in Cartesian form, you should be able to sketch it. So we've got one question to do, and you should be right to be able to do these on your own. And I'm going to jump in and I'm going to do question 6E, which is writing in parametric form. So I've got x squared plus y squared equals 9. And they give me x equals 3 cos t. Well, again, I've got two equations. I'm going to call this 1, I'm going to call this 2. And I'm going to sub 2 into 1. Now watch what happens. I get 3 cos t squared plus y squared equals 9. Well, 3 squared is 9. Cos squared t plus y squared equals 9. Remember, I'm trying to find y by itself. So I'll take that 9 cos squared t over the other side and I'll get y squared equals 9 minus 9 cos squared t. I'm going to factorise out that 9 and I get 9 out the front and I'll get 1 minus cos squared t. And again, I'm going to use the Pythagorean identity, the basic trig identity, which is cos squared theta plus sine squared theta equals 1. Why did I get that 1 in front of there? I'm going to take that, that's plus. I'm going to take that cos squared over the other side, and I'll get sine squared theta equals 1 minus cos squared theta. And that's true all the time. So now I've got 1 minus cos squared theta. I'm just going to write that as sine squared theta. So y squared equals 9 sine squared theta. Now square root them both. I'm only going to take the positive because it's a distance. 3 sine theta. And then I've got my parametric representation. X equals 3 cos, and I'll put, theta in there, and there when it should be t, 3 cos t, and y equals 3 sine t. Now that's all you have to be able to do. To move between Cartesian and parametric form for linear, quadratic, and circles. I'm not going to do any of the questions 9 and 10, or 8, 9 and 10. We'll do them in class, but you should be able to sketch them. And we'll be doing most of these in class. If you need to get ahead and you're wanting to come in late to class, you need to at least get up to, say, question 6. All right. Good luck.